Hello, my name is Zahra, and my talk is about information flow tracking for heterogeneous compartmentalized software. And this is a joint work with Anil Madhavedi from University of Cambridge. As you know, vulnerabilities exist in almost every layers of abstractions, from user space to systems to hardware, like and all the interactions between these abstraction layers. So historically, like isolation and compartmentalization and privilege separation based techniques are our main weapons against this increasingly complex systems and applications that we are seeing every day, and that is causing like even more and more like complex attack vectors. So compartmentalization is like getting more attention. We have more recently, like we have like confidential computing based, hypervisor based, capability based isolation. So this is an active area of research for protecting, for reducing the attack vectors of existing systems and existing complex applications. So more recently, hardware-based like compartmentalizations in almost every layers of abstraction, it provides isolation, such as like SGX and user space enclaves that's protecting the applications from even compromised OS or hypervisor. We also have very old trust zone based isolation that's providing kind of like a virtual core based system-wide isolation. We recently have SCV or TDX, and that you're providing the entire VM in memory encryption. So we have for the first time we have compartmentalization features in almost every layers of abstraction that is providing a very good opportunities for designing better privilege separation systems and both on almost all our architecture like ARM, Intel, and RISC-V, and this is a very unique opportunity. So we are already moving from a single compartment environment to a hetero-compartment environment where simultaneously there can be multiple compartmentalized software, multiple compartmentalized components with different isolation and enforcement and security model interacting with each other. And this is a model that our systems stack is not really designed for. We usually introduce our compartmentalization features separately, independently, with different security model and security requirements. And already there are different vectors in every single one of like the compartmentalization features that we introduce. For example, the most famous one probably is SGX enclaves, that there are all kind of like attacks, not only side channel attacks. Like there are systems based attacks, there are logical like attacks from the unsafe interactions of SGX enclaves with untrusted world. Like that can be another forms of enclave, like process is also like a form of OS based compartment, like the traditional units of isolation. And there are all kind of attacks from, like you can see some of them here, from like coin and like game of threads. And you can see that already just introducing two different, for example, compartment, different forms of compartment interactions together, it can introduce new attack vectors, more complex attack vectors, because we have limited like debugging and monitoring tools for like seeing what is happening inside the enclaves, inside the SGX enclave, and also the interactions with the outside world. Similarly, with, for example, trust zone, we have all kind of logical attacks, horizontal privilege escalation attacks, and also the traditional one, the boomerang attacks that was showing that you can compromise through a malicious TA, you can compromise also the entire system and like change the memory address space of the normal world. So the attack vectors can be really complex, and they can get really harder to debug, harder to find out, harder to monitor when we don't have the proper systems stack that are designed like with heterocompartment environment in mind. So in this paper we decided to attack this problem that when we have a heterocompartment environment, our system stack should also be ready for this kind of computing environment. So we introduced Deluminator for tracking information flows in a heterocompartment environment with the support for heterogeneous compartments such as SGX compartment, trust zone compartment, process-based sandboxing or like compartment, and also intra-address space based compartment for these kind of coarser grain component. Deluminator targets 5 main systems objects such as threads of executions, virtual memory for also like operating systems for IPC, RPC for interactions between cross compartments, and file systems and network sockets. So these are the kind of main systems objects that needs to be monitored. A lot of attack vectors at the end are related to one or multiple of these objects, and we have Deluminator enabled on Linux, in different layers of abstractions. And then we also have the similar the policy management and tracing systems that we implemented on the kernel also inside the trust zone environment, and also inside the SGX driver and SGX SDK. So to enable Deluminator, these components like the policy management and tracing systems should be ported. That's basically we describe the tracing systems in more details in the paper. This should be inside that trusted execution environment or compartmentalization based systems. And then there is the user space component, Live Deluminator, for the API to basically interact with Deluminator systems stack and tracing system. But the Live Deluminator is it can be ported. It doesn't need that much architecture specific modifications. Most of the architecture and systems specific changes are inside the Deluminator systems stack. And then when these components are in place in different compartmentalization systems, you can monitor the interactions of that compartmentalization features with other forms of compartment. So it can help with debugging, it can help with finding attacks, investigating attack vectors, and also if you want to have the same compartmentalized applications, for example on Intel and Trust Zone, and then you have the kind of same monitoring environment for both of them, so it makes migration to other platforms to use other kind of hardware-based compartmentalization systems easier. So we can benefit from more hardware features that are introduced in future. Details. So for Deluminator, the main thing that we needed to do is to finding the right abstractions for monitoring address spaces that we basically had to introduce, and kind of virtual abstraction layer for address space tracking, tagging, the blocks of contiguous blocks of virtual memory, that can be optimized with features for example MPK and MT and things like that. We also had to add new system calls that the number of these systems calls can be reduced to maybe 3 or 4. We haven't done this cleanup yet. But when you basically use these system calls, you can add that systems object, the address space file, and any object that you cared and you want to monitor to Deluminator monitoring system, and then you de-enable the tracing, and then you can see like how that object is like basically interacting based on the secrecy or integrity policy that like you assigned for that object. So we have the intra-address space tracking. That's the essential for proper like monitoring, and also the lib delimiter that is like providing a wrapper around all of these system calls to provide an easier way of like interactions with the system. We implemented Deluminator on Linux kernel with about like 8,000 lines of like code is changed or added or removed, like basically the modifications at the kernel, as well as some modifications on our TE systems for like both for like monitoring and tracking like information flows and tagging like systems objects. Like we rely on like opti for supporting our Deluminator driver in for trust on kernel, like secure world kernel, and SGX SDK for SGX based compartment. We evaluated our system. Like you can find the details inside the paper. Just a summary is that like we evaluated in like for both security and performance perspective. We tried running like existing attacks on like SGX based or like opti based like compartmentalized applications. With minor like application modifications, we could monitor and find this, for example, root cause of the attack, like monitor like what objects are accessed based on like secrecy or integrity violations. We also targeted like two real world use cases. One like interesting one is like the existing TE based ML frameworks. We targeted like one for darknet like ML systems that is ported to trust zone and SGX for in enclave ML computations, and then there are a wide range of like attacks, like multi-threaded attacks that like basically you can, for example, change the accuracy of like the model based on like dealing with the synchronization, and for example like this from the scheduler point of view, don't let the thread to like do the computation inside the enclave. So there are different forms of attacks that we describe in the paper, and we could monitor it with Deluminator. That we without Deluminator we didn't have like the option to do that. The other use cases was like SGX based and trust zone based, like for example OpenSSL and web services that now we could monitor some of the attack vectors, mostly existing attack vectors. So we didn't come up with kind of new ways of like attacking the systems, because already there are all kind of attack vectors. We wanted to make sure that we can just use this tool for attack investigations and auditing in existing systems. So in this presentation, we explain why heterocompartment environments are basically the future model of computing, and more hardware features that we are adding for better isolation and better compartmentalization. It cannot be really that secure to utilize if we don't provide better security tools and systems abstractions that are based on this model, not based on the historic like single compartment model. And that's why we introduced our work on Deluminator, that is kind of the first system that is providing the set of OS abstractions and user space frameworks for information flow tracking on a hetero-compartment environment between heterogeneous compartments from SGX or trust zone, and like process-based compartments and intra-address space system objects. And Deluminator is still has its own limitations, so it's needs a lot of future work supporting more form of like compartmentalizations, better performance, and also we are aware that like it's not fully automated. We need like minor modifications to the applications or the legacy applications if they want to enable the Deluminator tracing. So we will provide the code like on GitHub for like anybody that is interested to play with that and improve the current limitations. So thank you for listening to the talk, and please let me know if you have any questions or comments.